Now we're going to start to learn a new function. We have so many functions that we have to worry about, okay? So today, or right now, we're going to do exponential function. You probably have heard this before, right? Exponential function. Okay, so what is an exponential function? Just a quick review. We learned something. We learned a polynomial. So y equals like a 5x squared cube minus 3x plus 5 polynomial function. And inside the polynomial function, there are two special ones. One is x squared plus 5. So that's a quadratic. And y equals 3x minus 1. That's a linear, right? That's what we learned for the polynomial. And also we learned this. X plus 1 over 2x minus 1 rational, right? So we learned polynomial and rational, and inside the polynomial we learned quadratic and linear. Okay, so this is a history, okay? It's gone. Now today we're going to start this exponential function. I tell you what the exponential function looks like, okay? You can tell it's very different. It's very easy to recognize that, which is y equals, look, b to the x. Or you write f of x, a function of x is a b to the x. And here, the b has to be a positive number, and the b cannot be 1. If b is 1, then 1 to whatever power is just 1. So then we don't worry about that. So b got to be a positive number, and this b cannot be 1. This is the parent function of exponential function. The general form of that is a f of x equals a times b to the x. And it's very easy to remember because this b, we use b because this is called base. Okay, so this is called a base. Base is a real number, and a is also a real number. So from this parent function, if you know the graph of this parent function, when you graph this, you're going to vertically either stretch or press, vertically either shrink or stretch. So that is a times that. Therefore, we're going to do something more. So I want to give you some format. I give you some function, and you tell me which one is an exponential function. Okay. Now keep in mind of that. I give you the first one. H of x is negative 1 to the x's power. Is this a function? Well, it looks like an exponential function because we have this x at the exponential place, at the power, on the shoulder, right? I call this on the shoulder. X is here. But what happened to this base? This base is a negative number, so it's not a function, okay? So next one, g of x is x to the x power. Is this an exponential function? Nope. This has to be a number, cannot be a variable, so this is not, all right? And the next one, m of x equals 3 to the x minus 1th power. Is this a exponential function? We look at here, the base is a number, not a problem, and we have the x at this power position, but we only have not just x, we have x minus 1. This is a exponential function, but if you want to graph this from the parent function, y equals 3 to the x, what you should do is you should shift to the right horizontally by 1 unit. Okay. All right. So then n of x equals 2 times 5 to the power of x. Is this a exponential function? That's a very, very typical exponential function. Okay. That's a 5. It's a number, real number, to the power of x related to x, or just that, and here is times 2. All right, so that's n, and then let me give you 2 more. K of x is x squared. Is this an exponential function? It's not, because the base here, base is x. It's not just a real number. So that's not. This is quadratic. That's here, okay? That's a quadratic function. This is not a linear function. L log x equals 1 to the x's power. Is this a exponential function? We look at the base. What's the requirement for the base? It has to be positive and it cannot be 1, but in this case it is 1. Even here is x. So sorry, this is not. So if you look at all those things, that will help you to identify the exponential function. Every time we talk about exponential function, we talk about some features of that function, including domain, range, graph, things like that, right? So what is the domain? Domain. Exponential function. For exponential function, what is the domain? Remember that looks like this, a times b to the x's power. And this b, we have a requirement. This b got to be positive and cannot be 1, right? And a is another real number. And what happened to x? Let me tell you, this domain is all real numbers. All real numbers. Or another way to write it is from negative infinity to positive infinity. Any real number will do. Okay, so any real number could be this x. And what about range? Range is what y value could be. And we'll do this later, okay? And then graph. Okay, we might need to find the graph of the parent function first. Then we work on the transformation of it. All right. Now later we're going to deal with something like a little e and some compound interest. That was a different topic. Okay. Again, I said I would like to draw the graph of a parent function. I'll give you 2 examples. The first one is y or f of x equals 2 to the x. See, that's a b, right? That b in this case is 2. And I ask you to draw another one. G of x equals 1/2 to the power of x. All right. Now, in order to graph this, you might need to use a calculator. And what you need to do is choose x and to get a y. And here, the same thing. You choose some x and you get some y. All right, remember the domain is all real numbers, so we can pick anything. So we can pick 0, -1, -2, positive 1, positive 2. When x equals -2, which is 2 to the -2 power, and which is 2 to -2. And that will be 1 over 2 to 2. If you have a negative exponent, you can just bring that down to denominator and change the sign to be positive. So that is 1/4. Okay, so this is 1/4. And what about -1? 2 to -1, which is 1 over 2 to the first, which is 1 over 2. So here's 1 over 2. And 0, any base to the 0th power is always 1. Okay, this b cannot, as long as this is b, is not 0. Any non-zero number to the 0th power is 1. So here's a 1. And when x equals 1, that's 2 to the first, which is 2. When x equals 2, 2 to the 2nd power, which is a 4. See, you get some point. All right, we got 5 points. So we go x and y. And here is 0, -1, -2, and a +1, +2, 1, 2, 3, 4. Now, the first point we have is -2 and a quarter. So here's 1. So -2 and a quarter, and the -1 and a 1/2, 0, 1, 1, 2, 2, 4. We got something looks like this. Hey, I'm getting better, right? This is a graph that y equals 2 to the x. All right, very similar. Let's do this. Again, we choose this as my x value and then plug that in. When x equals -2, so that will be 1/2 to the -2 power, which is 1 over 1/2 positive 2, so that's 1 over 1/2 squared is 1/4. And 1 divided by 1/4, which means 1 multiplied by the reciprocal of this, so the answer is a 4. So here's a 4. And when x equals negative 1, 1/2 to the negative 1, which is 1 over 1/2 to the first power, which is 1/2, so that's 2. 0, here when the power is 0, it's just 0. X equals 1, 1/2 to the first power is 1/2, and the 2, 1/2 squared is 1/4. All right, now let me graph that. X, negative 1, negative 2, 0, 1, 2, 1, 2, 3, 4. That's my y. Okay. When x equals negative 2, y is 4, so that is this point. When x equals negative 1 and y is 2, when x is 0, to the power, what I'm saying. Okay, so here, and when x equals 1, that's 1/2, and it's a 2, it's a quarter. Okay, so I got the graph looks like this. This is y equals 1/2 to the x power. Okay, of course you can choose 3 to get a better graph. All right, now what do we know? You can tell the domain is what x value can be. X can be any number, right? Negative infinity to positive infinity, any real number, and here too. And then what is the domain? Domain. Negative infinity to positive, that's a domain. And what about the range? Depends, right? Or this one is increasing, this is decreasing, but the range is what y value can be. See, they're all from 0. It's all positive. Okay, and we're not touch the x-axis, is just the asymptote. So it's 0 to positive, to positive infinity. All right, so we got the domain, we got the range, and then let's talk about the if it won't touch the x-axis, so there's no x-intercept. What about the y-intercept? The y-intercept is the y value when x equals 0. When x equals 0, because y equals b to the x, right? And then when x equals 0, here's a 0. And we know that b is now 0, so the y-intercept is always 1. So it was, did you see that? It always passed these 2 points, right? Past that 1. So the y-intercept is always 1. Is this an increasing function or decreasing function? If b is greater than 1, it's an increasing function. If b is less than 1, but it has to be greater than 0, because remember it cannot be 0 or negative, then that's a decreasing function. Okay, and asymptotes. Is there any asymptotes? There's no vertical asymptotes, but there is a horizontal asymptote. So we have this horizontal asymptote, which is y equals 0, which is just the x-axis. Okay, so far we learned a lot about this graph. Next one. Okay, here I ask you to graph, okay? I will ask you to graph f of x equals 2 to the power of x minus 5. Now I want you to remember this. This is y, here's a 1, and when here's 1, here's a 2, and this is y equals 2 to the x. That's a parent function graph. Do you remember this? Now, if I ask you to graph this, 2 to the power of x minus 5, So you go from the parent function and you look at 5. What happened here is a minus 5, which means you're going to shift to the right by 5. So the graph will look like here is 5 and here is 1. So the graph will look like this. Okay. All right, so that means you shift to the right by 5. That's what it says. So far, so good? Okay, now next one. What if I ask you to graph this? F of x, I just call that f. It doesn't really matter. You can just use any letter. 3 times 2x minus 5. Okay, so we deal with this first. This is an exponential function for sure. So we have this b greater than 1, so we have like this curve, this kind of curve. So from the parent function, first thing you need to do is you're going to shift it to the right by 5. Okay, shift to the right by 5. And then you're going to multiply by 3, which means, see here's the x-axis. By 3 means for every y, you're going to triple it. For every y, you're going to triple that. So you're going to get something really sharp. Okay, it looks like this. And that is your new graph. Okay? And the next one, if I ask you to graph 3 times 2x minus 5 plus 1, do you know how to graph that? That will be from this graph, and then you're going to shift up by 1. Okay? Isn't it interesting? Yeah, kind of, huh? So that's a function transformation. All right, now after we learned everything here, we're going to learn something which is new. And you remember that I talked in early sections that a pi is a irrational number. Now we're going to do another one. I'm going to let you know another one. It's called a natural base. E. That is actually 2.1727 da 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 da. It's 171. Sorry, do it again. 2.71828 and 18 da, 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 da. Okay, it's just never stop and never repeat and never, just keep going. So that's an irrational number. And how do we get that? It's 1 plus 1 over n to the nth power. Okay, so let's see. If n equals 1, then 1 plus 1 over 1 to the first power is 2. Okay, when n equals 2, then 1 plus 1 over 2 to the second power, that will be 1.5 squared, which is 2.25. Okay, when n equals 3, then that will be 1 plus 1/3 to the third power, and it's 1.333 to the third. Okay, or you say that is the 3/4 to the third, and that's 2764 over 27, and then you can go ahead and find it. And n equals 4. You can keep going until you get n is really big to positive infinity, and then this 1 plus 1 over n to the nth power will approach to this 1.71828. So that approaches to E. Okay. Natural base. Because this E is 2.7 something, okay, because I don't want to remember so many numbers there. And this E is between 2 and 3, isn't it? So therefore, 2 to the power of x, 3 to the power x, e to the power x is going to, the graph of that is going to be between. So the graph of this y equals 2 to the x, when x equals 0 is always 1, when x equals 1, and that is 2. And when x equals negative 1, so that's 1/2. Therefore, I have some curve like this. This is y. This is y equals 2 to the x. All right. Now, what about 3? When x equals 0, here is also 1. When x equals 1, and that's a 3 here. And when x equals negative 1, I get a 1/3. So this is my curve. for this is y equals 3 to the x. What about a e to the x? What about a y equals e to the x? It's going to be some curve right in between these two. Okay, so if you want to use the graphic calculator, then you can see the detail. Anyway, we keep in mind that e is limit when n approaches to infinity, 1 plus 1 over n to the nth power. You don't need to know this. You don't need to remember this. You're going to use this a lot when you are studying calculus. Okay. So I'm going to tell you something about interest. Okay, the bank pays you interest. You put the money, you deposit the money in the bank, and we call this as a principal. Principal, that's how much money you put in the bank. And the bank pay you R. What is that? That's the annual interest rate. Annual interest rate. I think right now it's like a 0.04 or 4%. I just give this as an example. It might not be exactly the same. And then what's the other thing you need to know? Oh, A is the amount you get back. The amount that you get back after T years. You leave the money there, and then you're going to get the money back after T years. Now, the bank pay you interest of 4%, but they said something important. It's called a compound interest. What does that mean? If it's monthly, that means at the end of each month, the bank will calculate the interest, and then it's going to put the interest you earned to your account and earn interest again for the next month. So compound is a good thing because compound interest means you're going to earn interest based on the interest. So that sounds like a very, very good thing, right? And then when it's monthly compounded, then n will be 12. So n is the number of compounding period in 1 year. You see, that is why when I say compounded monthly, then that means n is 12. Okay, if I say compounded quarterly, then that n will be 4. If it compounded daily, that n will be 360 or 365. If I say compounded annually, means once a year, the n will be 1. Okay, so this n is just the number of a compounding period in a year. And here is the formula. A equals P, the principal, times 1 plus the interest rate over n. Here is nt. Now, we think about n equals 12. When n equals 12, that's compounded monthly. R over 12. Starting from the annual rate, you divide it by 12, you get the monthly rate. And the monthly rate, and this is at the beginning that you should have, right? Your principal, you have to have it. So this, after 1 month, you earn R over n this much interest. And then this n times t, n is 12, t is number of years. So that's how many compounding period in the whole time in t years. Okay, so let me give you one example. You put in $8,000 in a bank, and you put there for 6 years. Okay, and the bank A pays 1.2% interest rate per year and compounded monthly. And the bank B pays 1.19%, slightly less, but compounded continuously. I will do this later. Continuously. Which one should you choose, which means which one is better. We can work on the number 1 first because we know all the information here for the bank A. For bank A, we have a P for bank A, okay? Bank A. The P is $8,000, and the R is 1.2%, which is 0.12. Compounded monthly, so we know N is 12. How many years? T, 6 years. So we know all the information. We just plug in to see how much money we're going to get at the end of the 6 years. Okay, so that's 8,000 times 1 plus 0.012 divided by 12. 12 times 6. That is 8,000 times 0.012 divided by 12, which is 0.001 plus that, I get a 1.001. If you like, you can use calculator, no problem at all. To the power of 12 times 6, that's 72. So when you use your calculator, you know how to find 1.001 to the 72 power. Let me show you how to do that in the calculator. I think some of you might not know it. And here is 1.001 to the 72 power. Okay, what you should do is 1.001. And I want to see here. Did you see here x to the yth power? You click that, and then power of 72. Do you see this iPhone, when they updated their calculator, update the new system, and then the calculator get updated too, and you can get that equal. See, I get this guy, so which is this part, and then I just multiply by 8,000. Ding, that's how much money. So I will get, after 6 years, I will get $8,596.93. So I will stop at the penny, okay, 2 decimal places after the point. So this is how much you're going to get from bank A. Okay, now bank B. Bank B pays 1.19, but it's compounded continuously. We cannot use this formula. We cannot use this formula because this one is for compounding periodically. If you compound it continuously, that means for every second, every moment, the interest you earned, you're going to earn interest in the next moment. So that's the best thing. So you cannot do that because there's no n. N is infinity, right? All right. Oh, infinity? Hey, that sounds good because we have this n infinity. We got something looks like this, right? Okay, now I tell you, for compounding continuously, there's another formula. A equals P times ERT. You might want to take a little note. This is for compounding periodically. Okay, sorry, this is for compounding continuously. $8,000 again times E to the power for the bank B is 0.0119. Okay, because it's 1.19%, and then times how many years? 6 years. All right, how do you do this? Again, calculator. Calculator is so useful. All right, so I'm going to do this first. 0.0119 times 6 equal. Okay, I got that. I don't have to write this down. I just know. Okay, it's 0.07. Now I want you to see. Did you see the e to that power? Oh, they got an e here. So let me write it. It's 0.0714. Okay, so that's going to be e to the power of 0.0714. See, equals. And then I use this multiplied by 8,000. Okay, so the answer is 8,592.09. Very close because their interest rate is close. And this is compounding continuously, but because the interest rate is slightly less, and then you just get like a $4 or $5 it's almost like $5 less after 6 years, so it's really nothing. Okay, so this is how we use the E we learned today, and we learned some exponential function, and after that we did something just more than the exponential function, just made it fun. Okay, so right now at least you know how to calculate the amount of money you're going to get after you put the deposit in the bank, and as a fixed interest rate, and the bank will pay you either compounding monthly or compounding continuously interest. Okay, so that is everything you need to know for the exponential function.